Welcome back, everyone. Now, if you're a developer, maybe an engineering manager, or honestly just someone who has ever stared at an AI-generated codebase and thought, why on earth did it build it like this? Well, you are in exactly the right place. Today's explainer is all about a tool called OSpec. It's this brilliant, super lightweight, document-driven workflow that's custom-built for AI coding assistants. And we're going to see how it tackles one of the absolute most frustrating bottlenecks in modern software dev, which is losing your AI's context. Okay, let's dive into this. Our roadmap today is pretty straightforward. We'll start with the AI context problem. Then we'll be introducing OSpec, walking through its three-step workflow, peeking at the architecture and plugins, and finally wrapping up with some risks and our final verdict. Section 1, the AI context problem. So where exactly does all that context go? Seriously, think about your workflow right now. When an AI writes your code, where does its reasoning actually go? Honestly, it's a bit like a black hole. AI assistants are absolutely incredible at churning out code, right? But the actual requirements, the acceptance criteria, all those back and forth review notes, all of that vital context just kind of lives in this ephemeral chat window. And the moment that session ends or the chat just scrolls way out of view, poof, all of that valuable reasoning is simply gone. There was a recent article analyzing these tools, and it hit the nail on the head with this quote: "The code is in the repo, the reasoning is not." And man, that matters so much as your team leans more heavily into AI. Because if you ask an AI assistant why it chose a specific architecture, say a week later, well, the answer is whatever context you can painstakingly reconstruct just by reading the code backwards. And that is just highly inefficient. It really highlights a stark contrast between how we work and how AI works. In traditional manual coding, we naturally leave a paper trail. You've got pull request descriptions, chunky commit messages, review notes. That trail actually carries the decision path. But with AI coding, that rich, detailed trail gets compressed into a couple of temporary prompts. OSpec basically argues, hey, we shouldn't have to sacrifice a permanent, readable record just because an AI happens to be doing the heavy lifting. All right, Section 2, introducing OSpec and spec-driven development. So the crucial point here is understanding what OSpec actually brings to the table. It introduces this pattern called spec-driven development, or SDD. And OSpec itself, it's just a lightweight command line interface, a CLI. Think of it as a document-driven workflow layer that finally brings some much-needed discipline to your AI sessions. Instead of keeping requirements trapped in a chat UI, it actually attaches structured files directly into your repository. And it does this before, during, and after each AI-assisted change. The beauty of it is that both humans and AI agents can read and update these files perfectly. The core benefits here are just incredibly practical. First, OSpec aligns your context before a single line of code is even written. It also enforces a pretty strict rule to keep each requirement explicit, so it usually moves just one requirement through one active change, which totally prevents those massive, messy umbrella tickets. It stays super lightweight, and maybe best of all, it doesn't force you to ditch your favorite tools. It's built to work directly with Codex, Claude Code, and your standard CLI workflows. Moving on to Section 3, the three-step workflow: init, advance, and archive. Let's look at how this translates into your daily operational loop. The workflow is deliberately kept narrow and simple. It's just three explicit stages: initialize, advance, and archive. So first, you just run an initialization command once per project. Second, you create and advance a single change for your requirement and track it in a dedicated file. And third, and guys, this one is absolutely vital, you explicitly archive that accepted change only after your deployment and validation are completely wrapped up. Let's ground this in reality for a second. Imagine you need to add a password reset flow to an existing Node.js and React app. Without OSpec, that requirement is probably scattered, right? It's a random Slack message, a super vague ticket, and a prompt you quickly typed into Claude. But with OSpec, you actually prompt the AI to use OSpec to create and advance a specific change for this exact feature. When you do that, OSpec drops a structured set of files right into a dedicated .ospec directory in your repo. Boom. You instantly get a proposal markdown file, a generated tasks file, a state tracker, verification criteria, and review notes. Your AI assistant just fills in these tasks as it works. So if you close your laptop and come back the next morning, you don't have to go scrolling endlessly through a chat transcript to remember where you left off. The context is sitting right there in your file system, fully reconstructible by you and the AI. It's a real game changer. Let's shift gears. Section 4, architecture, and plugins. Let's look under the hood. Just a quick technical note to start. From a prerequisite standpoint, OSpec is super accessible. The official CLI package just requires a minimum of Node.js version 18 and NPM version 8 or later, and it just runs locally right alongside your codebase. Under the hood, OSpec is built on three main architectural concepts. First, you have the protocol shell, which is essentially your minimum collaboration skeleton, stuff like a .skillrc file for configuration. Second is the project knowledge layer. This provides explicit, permanent project context and docs that the AI reads consistently every single time. And third, the active change. That's the dedicated execution container we just talked about for a single requirement, holding all your tasks and state data. Now, OSpec also supports an ecosystem of optional, globally installed NPM plugins to really supercharge your workflows. Two standout ones are Stitch and Checkpoint. Stitch handles UI preview generation, which is awesome because it lets you review visual changes right alongside the matching code. Then there's Checkpoint, which acts as an automated verification layer built on Playwright to ensure key product flows actually work before you ship anything. They are incredibly powerful, though it is worth mentioning they are considered somewhat experimental additions to the core CLI right now. And finally, Section 5, Risks and Final Verdict. Let's talk limitations. It is absolutely crucial we take a pragmatic look at the current limitations, just so you can make an informed choice. Here's the objective reality of OSpec right now. First off, it is early-stage tooling. Based on our source data, it's hovering right around version 1.0.2, so honestly, you should expect some breaking changes in file schemas over time. Second, that archiving step we mentioned, it's manual. It doesn't magically hook into your CI/CD pipeline, so if you forget to run the finalize command, you're gonna accumulate stale changes. Third, it enforces a strict one requirement per change rule that requires real developer discipline to avoid bundling massive PRs. And finally, OSpec itself doesn't have any direct model integration. It manages the documents brilliantly, but the actual quality of the code and the task lists, that still depends entirely on how smart your chosen AI model is. So it all comes down to this final question. Are you ready to give your AI a permanent paper trail, or will your requirements continue to stay lost in the chat? OSpec fills a very specific but rapidly growing gap in modern development. It offers a straightforward lifecycle that literally stops your institutional memory from just evaporating between coding sessions. If your team is leaning heavily on AI for implementation, this document-driven approach is absolutely worth exploring. Thank you so much for hanging out with me for this explainer, and happy coding.